This is part 2 of the review sheet for the test number 1 in Calculus BC. Despereaux the mouse was found dead at 11:37 one morning on the castle grounds. Apparently he ate some bad soup. His normal body temperature is 96 degrees. His body temperature was 90 degrees when he was found at 11:37 and 87 degrees a half hour later. The room in which he was found was 72 degrees. When did Despereaux die? Remember, for this one, we do y equals CE to the KT plus the temperature of the surroundings. So we look at our information. C in this case is the original difference between Despereaux's body temperature and the room temperature. So C is going to be 24 degrees for this particular problem. We also know that the temperature of the surroundings was 72 degrees, and at the time he was found, his body temperature was 90 degrees. Now we have to set up a second equation to deal with the second piece of information. We know a half hour later, so I don't know what time he was found, or I know he was found at 11:37, but I don't know how long that was after he was found. But I know a half hour after he was found, so I'm going to say t plus 1/2. You can also say t plus 30 if you'd rather do minutes. Either way will work. I know a half hour after he was found, his body temperature had fallen to 87 degrees. So we can use these equations to solve for k, which will then allow us to figure out the time. So we need to divide these two equations, but before we do, we have to subtract the 72's over to the other side. So this is going to turn into 18 equals 24 e to the kt, and 15 equals 24 e to the kt plus 1/2 k. So I went ahead and distributed this k in and got kt times 1/2 k. When I divide, 18 over 15 reduces to 6 over 5. 24's cancel out. And when I divide, I subtract the exponents. So kt minus kt is 0, but then minus the 1/2 k gives you e to the negative 1/2 k. Take the natural log of both sides, and then divide both sides by negative 1/2. So let's plug that in and see what we get for our k. Natural log of 6 over 5 divided by negative 1/2 gives us this answer. And again, I'm going to plug that in for k, so I'll store that. So store alpha k. That way I can just type that in later and don't have to remember that big long number. So now we can go back and we can solve for the time it took between Despereaux's death and when he was found. So I'm going to use this equation right here and do 90 equals 24 e to the kt plus 72. And remember, we know k now. It's stored in our calculator. It's negative 0.3646 and so on. So first we subtract 72 from both sides and we get 18. Then we divide both sides by 24. 18 over 24 reduces to 3/4. Take the natural log of both sides to get rid of the e, and then divide both sides by the k. And again, we have that k stored in our calculator, so I can plug in the natural log of 3/4 and divide by k, which I have stored, and I get 0.7889. So I know it took that many hours between when Despereaux died and when he was found. So let's go ahead and convert that to minutes. So multiply that by 60. So approximately 47 minutes had passed. So let's look back at when he was found. He was found at 11:37 a.m. and we know that was 47 minutes. Yeah, 47 minutes after his original death, whatever. So 10:50 a.m. would be 47 minutes earlier, and that would be the time of death.